In this video, we will look at some properties of definite integrals, and then we will work on one example using those properties. This is the first property we have here. It says integral from a to a of f of x is 0. So basically this means if we have function f, let me quickly draw one arbitrary function. If we have a function f like this one, f of x, whose graph is like this, and we are looking at integral from a to a. So that means we are just looking at area under the curve from a to a. So there is no area, basically there is no region defined. So that means it must be 0. So whenever you are doing integral from a particular value to itself, the integral will come out to be 0. The next one says the integral from a to b of f of x is negative of integral from b to a of f of x. So this is basically saying if you change the order of the limits of integration, then it becomes negative. The integral becomes negative. Okay, the next one says if you have integral from a to b, then you can take any number c between a and b. So here c will be between a and b. And then you can write this as two integrals, one from a to c and another one from c to b. So what this is saying is if you have a over here and b somewhere over here, so this total area, this integral give you the total area from a to b. So we can split this into two areas by considering any number c between a and b. So if our c is over here, then I can draw two areas. Two areas like that. So I can say this will be the integral from a to c, and the other one will be the integral from c to b. So this is the area that is given by the integral from a to c, and the other one will be the area given by this integral from c to b. Here is another property which says integral of k times function f is simply k times integral of f. So we can always move the constant around. Here is another property which says integral of sum or difference of two functions is simply the sum or difference of two integrals. So all these properties are quite useful when finding definite integrals and also indefinite integrals. So next we look at an example. In this example, we have integral of x cubed from a to b equals 60. Integral of x from a to b equals 6. And integral of 1 from a to b equals 2. So first we want to find integral from b to a of x cubed. Using one of the properties, basically this one here, we get this to be negative a to b x cubed dx, because we want to write it in one of the forms given here. And this part here looks exactly like what we are given. So this becomes negative 60. Done with the first one. Let's look at the second one now. For the second one, we are looking at integral from 3 to 3 of x, function x, and using one of the properties again, essentially this one, we get this to be 0, because integral from 3 to 3 itself is always 0 for any function. Next, we are looking at integral from a to b of 5x cubed. Again, we want to try to write this expression in one of the forms given. For this one, using one of the properties, again using this one, we can move the constant 5 around the integral sign. So this becomes 5a to b of x cubed dx. Now integral of x cubed from a to b is given to be 60. So this comes out to be 5 times 60, which is 300. Next, we are looking at integral of -9 from a to b. Again, we try to write this in one of the given forms. So basically using the same property, we can pull that -9 out and write this as -9 integral from a to b of dx. Then this becomes -9 times 2, which is -18. Next, we have x minus 14. And this is a sum, well, a difference between two functions, x and 14. So we can just split this into two integrals using that property here. So we get a to b of x dx minus integral 14 a to b dx. So this we can write as the first part here is simply 6 as given. And for the second part, I can write this as 14 times integral of 1. So this will come out to be 14 times 2. And using our calculator, we get 6 minus 28, which is -22. So this is the fifth integral. Next, we have integral of 4x cubed plus 2x minus 17. So this, again, extending this property about sum or difference of two functions, we can apply to three functions. Here we have three functions, and we can do integral of each of these three functions and combine them. So this will look like integral from a to b of 4x cubed dx plus integral of 2x from a to b minus integral of 17 from a to b. And then I'm going to try to write over here so that I have more space. And then we can try to write each of these three integrals in the form we are given. So the first one, I can say this is 4 times integral from a to b of x cubed dx, plus the second one is 2 times integral of x from a to b. Third one would be minus 17 dx a to b. Now I can put the values we know. So integral of x cubed is 60, we have 60, plus 2 times integral of x is 6 minus 17 times 2. So this comes out to be 218. So this is the value of the sixth integral here.